Hello and welcome to my video assignment number 5 of my ME210 class. Today I will be talking about kinematics of a rigid body, just to give some background information as to how I came up with this problem. Today in the morning while driving to school, I pulled out of my driveway, and as soon as I tried to accelerate, my tires briefly slipped. This made me wish it was summer again, where tire slipping isn't really a problem. Now obviously whether something slips or not is a common topic in many of the chapter 16 and 17 problems. So this problem is based on if my tires hadn't slipped. Sometime in July, you leave your house to run some errands. You back out of the driveway and pull off. At a specific instant, while you were accelerating, one of your 2012 Honda Civic wheels with a radius of 0.317 meters spins at an angular acceleration of 10 radians per second squared. At that same instant, the very top of your tire, point A, has an acceleration of 12 meters per second squared. What would the angular velocity of your tire be at this moment? Obviously, we have our givens. We got the radius, angular acceleration, and the acceleration at point A. We want to find the angular velocity of the wheel at this instant. Here's a free body diagram. We have our radius from the center of the wheel to the end of the wheel. We have the acceleration of A. We have point A, and then we have the angular acceleration. Now the key concepts to solve this problem will be vector and scalar analysis, rotation and translation, kind of, relative motion analysis specifically for acceleration, and then also whether something slips or not, whether it doesn't slip. This is very important as this changes how you approach the problem. The key equations for this problem are A at the center of gravity equals angular acceleration times radius. This equation right here is very important. This is the equation you use if there is no slip, and only if there is no slip. If there is slip, then you have to take into consideration friction and then see whether or not it will slip based on static or kinetic friction coefficient. In this instance, our tires do not slip, and so we will use this equation, and then after plugging in our values for this, we will then find the acceleration at point G. We will then put it in to the acceleration equation, where we will then put in the rest of our values. And after that, we will just plug and chug and solve for the angular velocity. And this is a relatively simple problem, but it does take into consideration angular acceleration, angular velocity, velocity at a point on a wheel, and then whether something slips or doesn't slip, and how that changes your approach.